So I now am welcoming Jamie to the stage from Gloucester Academy. Jamie, welcome to the stage. Up you come. Round of applause.
Imagine you're gazing at the stars, taking the incredible beauty of the universe. But what if I told you something out there with a lot of mass, that makes up most of the mass of the universe, but we can't even see it? This mysterious substance is called dark matter. And while it's invisible to the human eye, we do know it's out there, as how it affects things around it. So to start to understand dark matter, we can have a look at galaxies. Galaxies made up of stars, planet, gas, and other bits and bobs. But galaxies also spin around a central point, just like in our solar system, when our planets are orbiting our sun. But with galaxies, there's a problem. They are spinning too fast. If we add up all the mass we can see, it only accounts for approximately 10% of the mass needed to keep the stars from being flung into outer space. But obviously, as we can see, this doesn't happen. So there has to be something out there with a lot of mass to provide the gravity needed to keep the stars in the galaxy's orbit. So this is what we have said to be dark matter. So you may ask, what is dark matter? There are many current canons for dark matter, but the one I am going to be talking to you today is the leading hypothesis of WIMPs and machos. These are acronyms for weakly interacting massive particles and massive astrophysical compact halo objects. WIMPs are a proposed class of particles that are heavy, slow-moving, and electromagnetically neutral, which means they don't interact with light. So perhaps we should have called dark matter invisible matter, but I guess we're stuck with dark matter for the time being. Machos are hypothetical objects like brown dwarfs, neutron stars, and black holes. Machos also have a significant contribution to the overall mass of the universe. That's why it is one of the leading hypotheses for dark matter. But with machos, we have discovered that there's not enough to make up dark matter. More specifically, perhaps we discovered about 20% of machos needed to make up dark matter. We've also said that this 20% of machos can make up dark matter, but the other 80% are made up of WIMPs. But like I said, this is only one hypothesis. Another hypothesis, I guess it could be that our current understanding of gravity is wrong, or just incomplete. But right now, no one knows for sure what dark matter is. Researchers are working around the clock, completing observations and experiments to slowly put together the pieces of the puzzle. Like I said, we're not sure what dark matter is, but we do know it's out there, playing a crucial role in shaping our universe. Thank you.
Wonderful. Okay, Jamie, diving into dark matter, let's go to our judges. And Joe, you know about a beautiful universe. Anything you would like to know?
Yes, well done, Jamie. This is such a big topic, so thank you for taking it on. How did you go about distilling all of your research into just 3 minutes?
That was a really difficult thing to do because there's so much about this topic. It's hard to pick what pieces should go into it. But what I was thinking is explain what we can understand with it, and then which one is the leading theory, which is WIMPs and machos. So it's I'll go into that and then maybe add a little bit of another theory, and then in conclusion, like that.
Thank you, well done.
Wonderful. And John, could I come to you for another question?
Thank you. So I noticed the title of your talk was What is a Great Unknown in Science? And obviously that made me think of all the things that could be unknown in science and where you might go with it. But often there's a thought that science deals with certainty and it knows everything, but actually it doesn't. So how important was it to you to talk about things that we actually don't know about in science?
Well, I guess, like I said, there's many unknowns in science. So it's good to know that people know that there's stuff we actually still don't know. So we always tell people the stuff that we do know. So it's quite nice to share to people the stuff we don't know.
Wonderful, wonderful, wonderful. Jamie, thank you very much for joining us, and you can head back to seats.